So the programming part now, that CNC lathe programming, CNC machining programming, and APT programming. So few more university problems I will take later. So let us study now CIM. CIM stands for Computer Integrated Manufacturing. So what is manufacturing? So manufacturer, it is derived from the Latin words manu factus, and the meaning is it is made by hand. The origin of the manufacturing enterprise, how it was originated. The first it was that water power. hmm. So water power was used for driving the machine tools and manufacturing. Then James Watt steam engine was machine using a water driven machine tool. So water driven means basically use of water turbines. So earlier all the machines were like say 10 machines or 15 machines or 20 machines were driven by one single prime mover. Prime mover means which rotates on its own. Prime mover means which rotates on its own, and the prime mover used to be a water turbine or it was engine. Okay. I am audible. The screen is visible, no? Hello, hello, hello.
Yes, sir. Screen is visible.
So there used turbine down, and then from the turbine, the drive used to go up. That is toward the ceiling, and on the ceiling you used to have a line shaft, and on the floor there is to be many machines, 10 machines or 15 machines, and then from the overhead line shaft every machine tool used to get the drive, and generally it was a bell drive. So you had a steam turbine or a water turbine or a diesel engine at the corner situated on the shop floor. Then there used to be a overhead shaft on the ceiling, horizontal overhead shaft. Then turbine, the drive used to transfer from turbine to the overhead shaft, and then from the overhead shaft, individual machines used to get the drive with the help of the belt. So this is how the driving system was, and this is how the manufacturing enterprise was evaluated. So manufacturing system can be represented by input. So you have some input, and usually we call it as a 4M. Usually the inputs are 4M. That is 4M means man, then material, then machines, and methods. That is what is called the 4M. So you should have man, hmm, and you should have material, then you should have machines, and then you should have methods. But sometimes the methods was replaced by money because you should have a funds, for any manufacturing system should have a funds, that is money. So now here from the examination point we will slightly modify it. So input means your customer demand, that is whenever there is a demand you produce. See, remember it is push production is no more there, it is always a pull production. Pull production means like whenever there is a demand, you produce it. Push production means you are producing the product and then those products are pushed in the market. That is push production. Means you have made 1,000 vehicles irrespective of the order, based on the history, based on the demand, and then you are pushing those 1,000 vehicles in the market. Full production means you have order of say 100 pieces or 100 cars, and based on that orders you are manufacturing the parts. So since you already have an order of 100 pieces, moment you manufacture 100 pieces, all the 100 cars will be rolled out of the factory. So there is no finished goods inventory. This is what is also called as the zero inventory. Zero inventory means not is the inventory of raw materials, because basically the inventory, there are four types of inventory. One is raw inventory, then second is work in process inventory, then third is finished goods inventory, and fourth is your spares inventory. The principle is zero inventory. Means what? You should not have any inventory. That is, whenever there is a requirement, that time you bring the raw material, process it, consume it. hmm, Like suppose I want to make 5 cups of tea. So I have order of 5 cups of tea. So immediately जाके मैंने sugar powder ingredients लेके आया, which will be used for 5 cups of tea. Then I processed it, and then it is consumed. So there is no finish inventory, there is no work in process inventory, and there is no raw material inventory. Spares inventory means like you need to keep some spares, important spares, because if your machine tool or your equipment goes out of order, then some spares are not available off the shelf. Off the shelf means like you just call them and they will deliver it. Some spares will take some time, 2 days, 3 days. Some spares are available only with the manufacturer. And if you are imported your machine directly from abroad, from the outside, if there are no local agents available in the parent country, then the transport time, packing time, and uh, available time. So it takes around 3 to 4 days. So 3 to 4 days you cannot afford to keep your machine idle. So that time the manufacturer itself advises that you keep these pairs if you want to reduce the downtime. So you have no choice but to keep some spares inventory, and spares inventory is maintained. Which spares inventory? The spares which the lead time is high, that is spares which are difficult to get immediately in the market. The spares which are easily available, you don't have to maintain any inventory. Right. So the present scenario is full production and it is not push production. Present scenario is zero inventory, but zero inventory theoretically it is fine, but practically it may not be possible. It depends upon you know the infrastructure. Very high degree of discipline should be observed in your logistic and in your infrastructure. So in ideal condition, fine, zero inventory. But ideal condition will never exist. So that's why you need to keep some amount of inventory. Earlier, but now the inventory, earlier it was 6 months inventory, then that was reduced to 3 months, then it was reduced to 15 days. Now we are keeping inventory for maximum 3 days, that is also for class A items, 3 days. Hmm. Otherwise many items, the inventory is zero. There is your suppliers, they supply the product, and that product directly goes on the line, on the assembly line, or uh, the where it is used, that is for the point of use. So the product directly goes to the point, it is stored directly at the point of use, that is what is called the POUS. If anything goes wrong with the supplied product, then supplier is responsible. The call goes to him, he has to come immediately, attend, rectify, and settle the problem. So whatever downtime till hmm, he arrives and he settles the product, it is counted. The loss has to be borne by the supplier. So in such scenario, the supplier makes it 100% sure that whatever he is supplying is perfect, because most of the MNCs, most of the big companies, they have, they have stopped doing the inspection. They have quality control and they have quality assurance, but inspection is no more. That is the responsibility of the supplier. Hmm. And supplier, again, inspection is not required. It is the process which is responsible for developing a correct or a good product. Inspection doesn't improve the quality. It is the process, and that's why, as an engineer, you should develop a capable process. Your process should be capable. Your process should be capable of developing the right product, the correct product. So, a manufacturing system is represented by input. You have some input and you are doing some processing, and then you get output. For an example, a pan wala, it's a manufacturing system. So the raw ingredients are the leaf, then that supari and everything. So these are the inputs. Then he does some processing and then he gives you the pan. Same is for the tea also, same is for the hotels also. So there are some raw materials, they do preparations. In the house also same thing. We have chawal, we have wheat, flour, and we do processing and we get output in terms of rice or in terms of chapati or uh, sabji, whatever it is. So, as I said, input is customer demand. Against the customer demand, since this is being full production, we do processing. We should have material, raw material. We should have funds. Then there has to be energy, for that is for driving the machine tools. Then man, and the man should be qualified enough, to do the processing. So processing involves your design, then your production, and your inspection, dispatch, logistics, stores, everything. So that comes under the management. So what is the output? Output is nothing but the goods, consumer goods, capital goods, then satisfaction, quality, and definitely cost effectiveness. Whatever you do, that should be that if you design, it should be designed for manufacturing. If you design, it should be designed for the cost. If you design, it should be designed for the assembly. That is, whatever you design, whatever you do, should be manufacturable at some effective or some competitive cost. And of course, the quality has to be maintained. Quality has to be maintained because if, if you compromise on quality, then you may not get repetitive order. So, what are the components of the manufacturing system? Components of the manufacturing system are production machines like your lathe machines, milling machines, drilling machines. Then material handling system. Material handling system can be your automated guided vehicles. Automated guided vehicles are short formed as AGV. It is nothing but like your tramways, which were there in Mumbai earlier, that is in 1960s. 1960s. So now also we have trams. I think in South Mumbai, that is Vadala and that lower Parel sides. So that is again a material handling system. It can be in the form of conveyor. Conveyor can be roller conveyor. It can be you know chain conveyor. So many types of conveyors are available. Gravity conveyor, chute conveyors. Then you can use simple trolleys or you can use pallets for metal handling, or it can be manual also if the distance is short. If the distance is long, then you can use pipe like in our petroleum industries, Burma Cell, etc. So we have ONGC plant at Uran, and then from there the uh, the petrols or diesels are delivered through the pipe to the various uh, pumping stations, like your Bharat Petroleum or your Hindustan Petroleum, which Bharat Petroleum, which is at Vadala, Hindustan Petroleum. They have processing plants at Washi. So that handling is done through the pipes. Pipe. Even the gas also. like our liquefied petroleum gas, LPG gas, or our domestic gas. That is also going through a pipe, gas ka pipeline. Then there should be a computer system to coordinate and to control the various components. And if it is now, at least in Mumbai, in India, there is not 100% automation, because the labor or the humans, peoples are available at reasonably acceptable cost. In the foreign, that is not so. In the foreign, mostly they believe in automation or unmanned operation. In certain areas, they don't get skilled humans, like in tool and die making. In tool and die making, Indians, especially South Indians is also Malayalis, they are very very skilled in die making. They have demand across the globe, because lot of manuals skills are involved in that. Mm. So there 100% automation is not done. Usually the automation is done where it is mass production. Uh, Again, certain areas are risky or hazardous. So there you have no choice, but you have to go for automation, like heat treatment plants where there is a fire. Uh, then even in medicines also, where there is a danger of infection. So the automation is done, like uh, checking the patients or aid patients or the diseases which can be infected through the touch. So there, the inspection or the diagnosis done through robots. Even the feeding of the tablets or even the feeding of the medicines is done through the robots. Those robots, they take the medicines and they feed to the patients, and so on. But India, the automation we are still into the semi-automation stage. That is neither totally manual and nor totally uh, automated. Like in case of automobile plants, if you see most of the plants, the painting department is 100% automated. Most of the plants, most of the automobile manufacturing plants, there you will not see single worker. Uh, uh, so because that is the demand of the customers. Customers now is not if you are able to give the blue color car, yes, he will take it. Otherwise, he will move to the next manufacturer. If you are not giving red color or if you are not giving yellow color, there are plenty of people who are ready to give. So that's why the painting departments are 100% automated. So how a manufacturing system is defined? It is a collection of integrated equipment. Integrated equipment, what? Equipments are integrated. They are joined to each other. Hmm? And human resources. So equipments and human resources are linked, whose function is to perform one or more processing, hmm, and do assembly, starting from the raw material part or setup. And believe this is a single piece flow line. Nowadays we call it as a single piece flow line. That is, the raw material enters at one end and the finished product is out at the other end. So there is no stacking of the inventory. So the work in process inventory is zero. The material is not waiting for the operations. The material is not waiting for the operations. The operations are being done continuously, and then raw material is processed. For example, your lock assembly line, the raw material enters and you get a finished lock. Then in case of furniture lines or cupboard manufacturing lines, Godrej, the raw material in the form of sheet metal enters, and then different operations like punching, pressing, joining, spot welding, then painting, then assembly of the cupboards, everything is done on the line. And then afterwards at the end you get a finished cupboard. So there is no inventory. Work in process inventory is zero. So that is what manufacturing system is, and it follows the principle of teamwood. Nowadays they are talking about lean manufacturing. We are talking about agile manufacturing. We are talking about flexible manufacturing. The manufacturing system can be classified as agile manufacturing and can be classified as lean manufacturing, classified as flexible manufacturing, and can be classified as reconfigurable manufacturing system. That is a new concept which is called as the RMS, reconfigurable manufacturing system. Flexible manufacturing system and RMS, there is a difference. Like in flexible manufacturing system means you have a manufacturing system which is capable of manufacturing a different type of models. Three models, different type of, or maybe 10 models can be manufactured. 10 different models can be manufactured on the same manufacturing system or the same manufacturing line. Earlier it was not so. One model, one line. If you want to manufacture four different models, 4 different lines. If you want to manufacture 10 different products or 10 different models, then you will have 10 different lines. Like in locks, now Godrej manufactures 35 different locks, different type of locks, including tijori, including 7 lever, 5 lever. So earlier they had 35 lines, for these 35 locks, but now they have hardly 4 lines, 4 assembly lines on which they manufacture these 35 different type of locks. So this is the scene is. So flexible manufacture means the product is same, one product only, but there are different models. On all the models can be manufactured in the same line or on the same line. And RMS, reconfigurable manufacturing system means you should design as an engineer, you should design your manufacturing system in such a way that today you are able to manufacture four-wheeler, tomorrow, that is tomorrow means within a day, with some little modification, you should be able to manufacture three-wheeler also, that is rickshaw. With some little modifications, you should be able to manufacture two-wheelers also. Like, we are talking about the toys, which the small kids they have. You know, they can make, helicopter, they can make two-wheelers. From the same component, they can, make different component. This is a typical or a good example of reconfigurable manufacturing system. So manufacturing system, your plan should be such, or your manufacturing should be such that you should be capable of manufacturing, entirely different products. So same line scooter, same line motorcycle, same line four-wheelers car, same line three-wheelers rickshaw. Of course, with little changes, with little changes, because changes will definitely will be required. Maybe you will have to do some modifications, some raising, lowering, some kinds of addition, some kind of removal. But it should not take more than a day. So within a day, you are capable of manufacturing four-wheelers or two-wheelers. So that is what is called the reconfigurable manufacturing system. And lean manufacturing is nothing but reducing the waste. They have classified the waste, that is seven waste. So lean manufacturing, it's a mindset basically, and it believes in reducing the seven waste. That is team mood. Team mood. I explain the full form of team mood. TIM. That is and WOOD. That is first T. That is the loss due to transport, then loss due to inventory, mm, and so on. Mm. So that again, when we'll discuss about lean manufacturing, I'll take it. So the equipment will includes your production machines, your material handling, your computer system, and the human resource as well. Now, this is what is your manufacturing system is. So you have at enterprise level, at factory level, then all these, are linked. All these are linked. Manufacturing processes and assembly operations. So you have material handling technology, you have automation and control department. Hmm. So all, then you have quality control, then you have dispatch, then you have feedback systems. So all these are linked and they're working simultaneously. Traditional approach was the marketing peoples or the sales people, they will get the order, they will not ask anybody. Order लेके आया बस. I have got the orders. Target दिया है तो मैंने order लेके आया. So the traditional approach was marketing. Everybody will work as an individual, independently. That is, sales, marketing people, they will get the order because they had been given targets by the top management. So they will not ask your design people or purchase people or production people कि जो मैंने order लिया whether it can be manufactured or not. No, they are least bothered of that. तुम उधर कुछ भी modifications करो और ये order बनाओ. Okay, ऐसा. Then again, then design people. The design people will manufacture or they will they will design in such a way that it cannot be manufactured. Usually this happens with fresh engineers. Then planning peoples. So they will plan in such a way that is they will not ask production peoples what is going on now. uh, they will simply plan, yes, this component has to go on this machine. ये machine के ऊपर इतना time जाएगा. Okay, and that's then further it will be assembled and then it will be dispatched. Like everything is available, and then everybody is stuck. प्रोडक्शन वाला बोलेगा अरे अपने पास मशीन ही नहीं है. He will tell to design whatever your design, you come and show us how to manufacture, how to make it. Whatever your design is not manufacturable. Quality control people will say or inspection people that uh, testing facilities are not there for this particular product which you are designed and manufactured. We don't have testing facilities. So like these things happens, and this is what is one of the traditional systems. And now currently the present manufacturing system is concurrent engineering. That is, everybody works in tandem together. Everybody is linked. Everybody is linked to each other. They will marketing वाला बोलेगा पूछेगा अरे ये ऐसा ऐसा प्रोडक्ट है लेकिन उनको ऐसा ऐसा चेंजेस करके चाहिए. So can we do that? So this is how the system, present manufacturing system works, and that is what is called as the concurrent engineering. Hmm. So, and that gave rise to a new manufacturing enterprise bill, which is also called as the CIM bill. The CIM is nothing but integrated manufacturing. So your manufacturing, which is integrated with the help of the computer, with the help of the computer. Like if you take an example of bank, it's now core banking. All the bank branches are connected to each other. If you want to print a passbook, you don't have to go to your home branch. You can print it anywhere. You can update it anywhere. Your ATM card, debit card. First time only you have to go to the the ATM, the branch ATM. But later on, you can go any ATM and you can get the money. You can deposit the money. Hmm. So this is because of the concurrent engineering, because of the networking, because everybody is connected now. Hmm. Whether he's in India or whether it is in USA. So this is what is your computer integrated manufacturing. And the same wheel which I was talking about is this. I'll just zoom it. Usually, the repetitive question is your describe the same wheel, and it ranges from 5 marks to 10 marks. So suppose if it is for the, see whether it is 5 marks or 10 marks, you need to draw this wheel, and depending upon the weightage, you have to explain. So if it is for the 10 marks, we expect that you should write two-page answer. Means you not only you have to draw the wheels, but you need to describe each and every department in at least 2 or 3 lines or 3 to 4 lines. So for the 10 marks, minimum 2 pages answer is essential, because it will, to when you are describing so many things, it will go to 2 pages. Like, what is your business definition? Hmm? What is your system design? See, it is divided into, first thing it is divided into people, teamwork, and organization. And it is customer specific, customer centric. Remember, customer, if you don't have a customer, then, or if there is no customer, we will not exist. Customers can be internal, customer can be external customer. The customer is king, customer will dictate. Understand? So customer satisfaction. Customer should be happy. Customer should be happy. Customer should be satisfied. So we talk about customer satisfaction. Hmm? And there is a teamwork, then you have organization, then we have product and processes, which is followed by manufacturing, which is followed by the customer support or the customer service. So integration of all this is nothing but computer integrated manufacturing. So we have people, then materials, then tools, that is your machine tools, that comes under the category of resources also, then information, then technology, suppliers, all these are interconnected. Employee, investor, community, responsibilities, regulatory, that is you have to follow the norms, that is environmental norms, which whatever you do should be environmental friendly. So if you are a process industries, that is if you are manufacturing chemicals, then you have to follow the norms, that is you should have a ETP plan, that is effluent treatment plan. Either you have to send your effluent, hmm, to the very far distance. Of course, by treating it, you cannot just send your chemicals, or the waste directly to the sea. So you should have a ETP plan, effluent treatment plan. So you have to treat your effluents and then send it to the sea. Same, suppose if you are generating gases, like suppose if you have a boiler, then the gases should be laid into the atmosphere. So you should have a chimney Take an example of textile mills. They had huge chimneys. Even the bakery also. If you have seen if you have noticed the bakery also should have a chimneys. So you have to follow uh, the rules and regulations, and you have to protect your environment. Right? So in customer support, in customer support, you have to uh, take the feedback which is very important from the customer. You have to give the service to the customer, which is again very important. If you don't give proper service, then customer will not give the repeat order. See, your business is nothing but the relations. Business is nothing but the relations. The more the repeat orders you are getting, that means it's an indicator or it's a sign of you know good manufacturing. All right. Now this manufacturing will include your material management, mm, your assembly, testing, or if you start from here, it is resources planning. Now resources means your man, resources means your raw material, resources mean your equipments, your machine tools, anything, resources which you are converting or which are helping for manufacturing. Then you have operations planning, that is a work of process engineer which you are going to learn in process engineering and tooling. Then you fabricate your component, that is what is called the component fabrications. Hmm. And then you assemble it and test it, and followed by dispatch. Now dispatch, as I told, that you should not have finished good inventory, so the finished product should reach to the customer, directly to the customer. Because if you are going on producing, and if it is not rolling out, if it is not reaching the customers, then finally it will come to standstill. So you will have to stop your production, because where you will store your products? Do you have space? Do you have godowns? Do you have warehouses? Hmm. Maybe warehouses, etc. You have facilities of storing maybe for 5 days or for 10 days. But if it is not rolling out, if it is not reaching the customers, then after 10 days तो आपको प्रोडक्शन बंद करना पड़ेगा. Exactly. Hmm. So this is what is very important. The same way. So the elements of the same will are customer. Then PTO is not a please turnover. PTO means people and teamwork in the organization. See, teamwork is very much essential in any organization. Yeah. And team, even if it is made up of one person, hmm, like Panwala thought, for him also teamwork is important. There is a team because he is also getting raw material. Uh, he is also delivering, finished good to the customers. So he also has to work in team. Understand? No? Then only he will be able to make the business. Then there has to be a sharing of the knowledge. Otherwise, that goes into the monopoly. Hmm. Then processes. That is how you are going to manufacture. Then resources and responsibilities. Everybody has to be given responsibilities, because if you don't assign responsibility, then the organization will not function. Hmm. And responsibilities will be from lower one to the higher one. That is, lower one means even the sweeper has a responsibility, and even the CEO has a responsibility. Only, I mean, the CEO has more responsibilities because He has the responsibility of the entire organization, whereas the sweeper is responsible only for cleaning a particular area. But so he may have the sweeper or who is at the bottommost. It's a triangle actually. It's a triangle. The peoples who are at the bottom of the triangle, that is at the base level, they have less responsibility and more physical work or mental work, whatever it is. Like a sweeper, he has more physical work, लेकिन responsibility ज़्यादा नहीं है. Whereas who are at the apex or at the vertex of the triangle, like the CEO, they have less physical work, but they have more mental work and they have a lot of responsibility. Hmm. The entire plant has to run, in profit. That is what is their responsibilities. And nowadays, so even the customers can direct like Mahindra. See, it's very open. The customers, if anything goes wrong, the customers they have liberty to contact directly to the presidents or directly to the CEO. They can write to him. This is what the problem is with your product, and that's how they improve. So the people who are at the top or at the vertex of the triangle, the responsibility is more. And of course, you should have a very good manufacturing infrastructure. Then the customer, it is customer centric. Remember, it is customer centric. So customer is the hub, of the wheel. So you have to satisfy the customer. You have to understand the needs of the customer, and accordingly you have to deliver. That is what the present manufacturing is. Like I give an example, like if the customer wants Fatela jeans, torn jeans, then you have to manufacture Fatela jeans because that is the need, that is the requirement. Earlier, in I think in 19s, the pants they had the pants were bell bottom. Bell bottom. That is the bottom of the pants used to look like a bell. If you now if you see those pants, you that is outdated. You may laugh. And then nowadays it is all narrow bottom. Hmm? Or the pants are coming right till the waist. Don't know when it will fall down. Sorry. So as I told that it's nothing but a teamwork and the role of the engineer who are working on the shop floor especially is to take his entire team with him and achieve the target. If there is no teamwork, then it is very difficult to achieve the target. Then there has to this is what now explain of each and everything from that CIM wheel, which I already explained. You have to share the knowledge, and nowadays everything is available at the click of the mouse. Hmm. So these are the 15 key processes in design, manufacture, and customer support. This table is important. This like you define your objective, what you want to do, hmm, whether it is manufacturing or whether you want to go into the service. Then system design, that is overall. Then component design, that is you come to the component level. Hmm. Continuous improvement is always important. Continuous improvement is always important. Whatever small it may be, whatever small it may be, hmm, but there has to be improvement. And remember, as an engineer, you should work for development. You should work for improvement. You should not be busy with routine work. If you are busy with routine work, then there is no use of doing engineering because in routine work can be done by diploma holders or by ITI or even by the peoples uh, who have been working for 5 years or for the 10 years. So as an engineer, you should always that you develop, and if you develop hmm, the manufacturing, then obviously you your growth is also going to happen. Nobody is going to stop from your growth. The management has to consider your growth. Yes, he has done something to my organization. He has developed the product. He has reduced the time. He has uh, reduced the rejection. Hmm. So management will definitely take care of you. So remember, continuous improvement is, and we are not achieving. We are not talking about big improvement. We don't want breakthrough. Small improvements, small improvements will make the big improvement. Documentation and release is important because every now if you want to go into the exports, basically, then you have to be certified. ISO certified, BVQI certified. So the certification is important. That is what is for the documentation. And documentation is important in the sense that today, suppose tomorrow, suppose if you are not there or if somebody is not there, then the somebody else who is taking over can go to the documents, can go to the SOPs, and maybe in the initially there will be slight delay, but maybe within 1 hour or within one day, once he goes to the documentation, with the proper documentation, then he will be able to take over the manufacturing. Then in manufacturing, you have resource planning, that is equipment man, in operations planning, that is how to do. Then component fabrication. Now fabrication doesn't means only welding, brazing, soldering. Making a part on the lathe machine, making a part on the milling machine, that is also a part of the fabrication. Then you assemble it and test it. Material management means that is work in process inventory should be zero. Then customer support, that is hmm, you have to see that your product go in the globe. You have to distribute accordingly. You have to plan the logistics accordingly. Sales, and you have to see that you keep on promoting your product. You give good services to the customers. And uh, life cycle transitions means after some, that is life cycle management, that is after certain time you have to see that your product retires from the market and you launch a new product, you develop a new model. That is what is your life cycle transitions means. So we'll stop here, because you are waiting for the break. If you have doubt, you can ask, otherwise you can leave.